This learning object is a production of Abu Dhabi Men's College, Center of Excellence for ICT and Learning Technology.
Sustainability in engineering has taken precedence in society, and particularly with the uncertainty that we are facing in regards to climate change and global warming. This has also exacerbated the problem, the recent changes of the financial crisis that has taken the world by storm. You might ask yourself, what does have the financial crisis to do with sustainability? Well, it probably doesn't have much to do with it, particularly as engineers, but in terms of the relevance of designing something that is sustainable for the long run, there is plenty of room for engineers to contribute to that argument. Further to that, what we would like you to learn today, or perhaps open up your thoughts to, is that traditionally sustainability has not been a science that's been taught at a university or high school level. So most of the knowledge that's coming up at the moment is recent, and it is still developing. And there is no sustainability science or a domain that you can actually go and undertake studies in. That is still developing. Therefore, as engineers whom contribute a certain amount of change to society, we need to be aware of the concepts that drive this movement. And previously, I've actually quoted Duran, and Duran was he came around the period after the Second World War where the US and Japan were competing in their manufacturing sectors. And the reason I want to refer to Duran and perhaps even Deming, whom they were both great scholars in the quality movement, Duran actually said that quality is free, because if you actually design for quality or if you build for quality, eventually with the efficiency that you achieve, the savings will pay for itself, whatever capital that you would need to invest. Similarly, Deming had to actually look at the concepts behind why do we do things that way, and combined between Duran and Deming, they said, well, why do we not do it the first time and do it right? Do it right the first time, and therefore we won't need to revisit it. Similarly, with the concept of engineering design, we need to be aware of what is actually happening around the resources that we use. So therefore, with the unprecedented economic growth that we've had over the last 20 or so years, whilst we've had our ups and downs, and everything is cyclical in the economy in particular, there had also been a significant amount of pollution or perhaps environmental degradation due to the economic growth. So you cannot have one without the other. The two go in hand. Therefore, understanding our awareness of the concept of sustainability, what we need to look at as engineers, why do we need to be concerned with sustainability? And sustainability is not just about recycling, as we see our little friend here running in the 3 recycling arrows. So it is crucial for engineers to learn about sustainability, to have a deeper understanding of the environment and the threats that we are facing as humanity. So therefore, as lifestyles that we consume every day and what we use in our daily lives, how do we contribute to sustainability? This is the question. As an engineer, when I studied chemical engineering, and most of us have had some relevant field of science, we have been taught to convert anything into anything. And what we see from the diagram here at the moment, there's plenty of talk today of pumping CO2, whether it's in liquid form or gaseous form, and particularly with the coal-fired power stations and all the emissions that we are facing today, of pumping it into old reservoirs underground. Therefore, that's one way of capturing the CO2 and limiting our global warming effects. Similarly, we are greening the deserts. We are genetically engineering crops. We're growing trees in places where they shouldn't perhaps be grown. And more particularly, we have created enough aerosols in the stratosphere to create a giant reflector. which is contributing to the whole climate and greenhouse issues. So therefore, as engineers, we have always designed things and we've calculated numbers to 3 or 4 decimal places. And perhaps when you're referring to safety, you have also calculated things for second or third factor. So if you've designed something for, let's say if you designed a bridge, as a safety factor, multiply whatever calculations you've determined by 2 in order to be safe. But have we really considered, safety is one aspect of it, have we considered the other aspect, which is the environmental cost of this particular design? We do not need to sacrifice or compromise the safety. But what we're saying is just how we calculate for safety and we calculate to 3 and 4 decimal places, we also do need to calculate for environmental sustainability and the eco-efficiency of your product or your design or your manufacturing process. So therefore, as engineers, we build with resources that are available. Similarly, 20 or 30 years back, this wouldn't have been possible. Even if it was possible, it'd probably be the size of the whole body of this person rather than the miniature size that it's in. So therefore, whatever resources are available, whatever technologies, engineers actually try to utilize it to come up with solutions. Now I will actually hand over to you and ask you a couple of questions. What is your definition of sustainability? Do you have one? Should you have one? Is it thinking about materials that we use in our design? Is that sustainability? Is it thinking about where they come from? Or trying to choose material that will have a low environmental impact? If you do one of these 3 things, does that achieve sustainability? That's what I'd like to leave with you, and we will come back and revisit this by the end of this discussion.